So this is the first session of Signals and System, and in this session we will discuss everything about introduction to signals. So let us start the discussion with the definition of the signal. So basically a signal can be defined as any physical quantity which contains some information and varies with respect to one or more independent variable. So what exactly an independent variable is, that we will discuss in our upcoming slides. But for the time now, we need to understand what exactly a definition is. So a signal can be defined as any physical quantity which contains some information, some message, and varies with respect to one or more independent variable. So here are the few examples of signals: the human voice or speech signal, the still photograph, or you can say image signal, heartbeat, sign language, Morse code, traffic signals, voltages on telephonic wires, electric fields emanating from the radio or television transmitters, variations of light intensity in an optical fiber on a telephone or computer networks. And at last, we will discuss something about noise, basically which contains some undesirable information, or you can say the information which is not at all of useful, which is not at all of our use. So here are some pictures, here are some images which I have put here. So as you can see, this is an example of human voice or speech signal. This is one image signal. As you can see, examples of image signal, Morse code, which is mostly used in the military applications where the signals are transmitted and decoded. So as you can see, this is a sign language, and this is one example of ECG signal. Now next we will discuss some points about the noise. Now every signal carries some information. However, not all that information is typically of interest to the user. The goal of signals processing is to extract the useful information from the signal. The part of the signal that is not useful is called noise. So noise is not necessarily noisy. Any part of the signal we are not interested in is by definition is called noise. Now usually the information carried by a signal will be a function of an independent variable, as we discussed in the first slide. The independent variables can be time, spatial coordinates, intensity of colors, pressure, temperature, and etc. So these are all the examples of independent variable. Now the most popular or most common type of independent variable in signals is time, and it is represented by the letter T. So the value of the signal at any specified value of the independent variable is called amplitude. Okay, that is called the amplitude. The sketch or plot of the amplitude of a signal as a function of independent variable is called the waveform. So as you can see on the screen, this particular figure has x-axis, it has y-axis. So this x-axis, which is a domain, is in time domain, and the y-axis is amplitude axis, and this amplitude is a function of time. As you can see, x of t, the time is t and the amplitude is x of t, and this particular signal is varying from source to destination, as you can see. Now here you can see there are some examples of signals which are dependent on single independent variable, and some are dependent on multiple independent variable. So as you can see, the first equation, x1t is equal to 0.5t, this is the equation number 1, has only one independent variable, that is t. x2t is equal to 2.5 t square, which is equation number 2. It also has one independent variable, that is t. The third equation has two independent variables, p and q, and is represented as 0.2p plus 0.5 plus 2.5 q square. So the equation number 1 varies linearly with respect to time. As you can see, this is a linear equation, or you can say it is the equation of a straight line passing through the origin. Equation number 2 varies quadratically with respect to the time. So this is a quadratic equation, or you can say it is a parabolic equation. It is also passing through the origin. but it is non-linear in nature. The third one represents a signal which is function of two independent variables P and Q. So we discussed everything about signal, the definition, the noise signal, some examples. Now let us discuss about the classifications of signal. So here are some classifications of signal. Depending on the number of sources for the signal, a signal can be categorized in two types, one channel and multi-channel. Second is depending on the number of dependent variables. It is divided into two types, one-dimensional signal and multidimensional signal. Third one is depending on whether the independent variable is continuous or discrete. Remember, I said independent variable, or you can say the domain. Okay, whether the domain is discrete or domain is continuous. It is divided into two types, continuous time signal and discrete time signal. So basically, as it is written continuous time signal, that means the domain is time axis. The domain is time. Now, depending on whether the dependent variable is continuous or discrete, it is divided into two types, analog or continuous signal, discrete signal. So these are all the classifications of signal. One more classification is there, classification of discrete time signal, or you can say continuous time signal also, depending on their characteristics. So depending on the characteristics, how many different types of classifications are there, that is given here. The first one is deterministic and non-deterministic signals. Second one is causal, non-causal and anti-causal signals. Third one is symmetric signal, which is also called as even signal. Anti-symmetric signal, also called as odd signals. Fourth one is periodic and non-periodic signal, which is also called as aperiodic signal. And the last one is energy and power signal. So these are the classification depending on their characteristics. So let us first discuss about the one channel versus multi-channel signal. What is the difference between one channel and multi-channel signals? So signals that are generated by a single source or sensor are called one channel signal, and the signals that are generated by multiple sources or sensors are called multi-channel signals. So as you can see, one example is given here. If we need to record the temperature of a room, we need a temperature sensor. Then the recording of the room temperature by the help of a single temperature sensor is an example of one channel signal. Now in the same way, if you need to record the temperature and humidity of a room, then you can say you are using two different types of sensor. One temperature sensor, another one is humidity sensor. So this is called as multi-channel signal. Now one more example is there under one channel, that is the audio output of a mono speaker. As you can see on the screen, this is a mono speaker. So the audio output of this mono speaker is called your one channel signal. The audio output of two stereo speakers is the example of multi-channel signal. One more best example of multi-channel signal is the record of ECG at 8 different places in a human body, that is 8-channel signal. So you can see there are some leads which are connected on the chest, or some hands which are connected on the chest, hands, legs. So these are 8 channels, 8 wires, 8 leads which are connected to the human body are the best example of multi-channel signal, because they produce different types of information from the human body. Next is one-dimensional versus multi-dimensional signal. So basically a signal which is dependent on single independent variable, then it is called one-dimensional signal. And a signal which is dependent on more than one independent variable is called multidimensional signal. So the example is music signal, speech signal, because they depend on the time, they depend with respect to the time only. The domain is time itself. Photograph, or you can say a still photo. So a still photo has two independent variables. The intensity and the brightness at each point of the photograph is a function of two spatial coordinates, x and y. The motion picture depends on three spatial coordinates: intensity, brightness, and time. This is another example of multidimensional signal. So this is all about one-dimensional and multidimensional signal. So there might be so many other examples which can be under this category. So in this particular lecture, we have discussed what exactly a signal is, what are the independent variables, what are the different examples of signals, what are the different classifications of signal, and basically in this particular lecture we discussed about one channel, multi-channel, one-dimensional, multi-dimensional. Now rest of the things, the discrete, the continuous time signal, the discrete time signal, the analog signal, the discrete signal, that we will discuss in our upcoming lecture. Thank you.